Hello again. I'm Steve Wells. I'm a fellow working at Micron, and we get the privilege of talking about standardized telemetry with also Mike Allison. I'll let him introduce himself. Also his second time presenting this morning. So the conversation is around standardizing the storage telemetry. So we'll give you some motivations of what we're trying to do, why we're trying to do it, and go into some of the nuts and bolts of how we're going to do it. So our current solution today for monitoring and debug, there are multiple standardized SMART pages floating around. There's no vendor-unique SMART opportunity. And that's because if you look at either the NVMe or the OCP SMART page, any of the unallocated fields are declared as reserved. Reserved means they must be 0. So, and rightfully so, if you started adding vendor unique stuff and then the spec wanted to add more, the next generation of spec, it would stomp on top of that. So that really gave no opportunity to add any of the vendor unique SMART. Well, what would be your option then? It would be to add your own log pages in the vendor unique space for that. The OCP data center NVMe specification does not allow vendor unique SMART specifications outside of the specification, and that's the famous SEC 19 rule, without prior written consent from the customer. So interested, I think we're going to see more data sheets. We're going to see an SEC 19 statement of, well, what were some of the vendor unique stuff added to this? From a telemetry perspective, the OCP spec did offer guidance that says use data area 1 for fleet monitoring, but really offered no payload guidance. So what was going to be inside of there would be completely vendor unique. Decoding that information was going to be challenging. And then within the, if you know, dump into the details of the telemetry spec of NVMe, there's also a reason identifier. And there was really no guidance given on the reason identifier payload as well. So everything inside the reason identifier of if you had a problem, what did that mean? And finally, the famous one, SEC 22, specified that this stuff needs to be decoded human readable. And there was a lot of questions, at least I know I kind of annoyed some of the OCP authors when I said, what constitutes human readable? Is that noun and verb and what language? Or what does it mean to be human readable? And so, our current solution ultimately required any sort of fleet monitoring to require multiple IOs if you wanted to cover all of the SMART pages, potentially some vendor unique details. The debug was strictly vendor unique, and there was really varying interpretations of what even human decodable meant. And that meant there was, for end vendors, there would be end decoder tools as well. And so as an initiative, a part of OCP 2.5 spec, we've worked on a new standardized telemetry model. And at a high level, what we're standardizing is the telemetry payloads in data area 1 and 2, as well as the reason identifier. So Mike will go into some more details on this. I'll show an analogy here, which is for you that are slight car enthusiasts, and I'm a somewhat car enthusiast. There's a standardized debug port on your car, and every time you go to the shop, they plug into the computer and go read it out. It's a standardized connector. It has a standardized protocol, but it is VU extendable. So I get a very different answer on my hybrid electric car than I do my 15-year-old pickup truck when I plug in this thing. So it has a way of offering vendor unique specific implementation or architecture details in there in a standardized way. And that's what we're trying to gun for here. So we're going to offer a single low latency kind of one and done data area 1 fleet monitoring. It incorporates some of the other existing SMART pages, so it becomes a simple single IO periodically pinged on the drive for fleet monitoring. There's statistics that Mike will go over in detail, but these statistics allow for not only health monitoring, but also some opportunities for load balancing as well. So some of those statistics will give you a hint of whether in your fleet of drives, if some drives are becoming close to oversubscribed and other drives are a little empty. And then potentially you could use, in theory, something like live migration to try to load balance some of that out. It does support vendor unique statistics and event FIFO capability, but it allows it to be added in a standardized way. Very similar to my carport. Allows me my newer electric vehicle statistics and parameters can be looked at, but done in a standardized way. There's a standardized debug method for post-panic in data area 2 and the reason identifier. We'll go into that in a bit more detail. And this offers an opportunity, and this is our plan, is to have a single decode tool for everybody. Just like my engine diagnostic computer can plug into a Ford, a Chevy, maybe not a Tesla, well, actually some of the Teslas, but this will simplify and improve debug productivity by the fact that if there is a health monitoring or debug consideration that you want to go look at, you don't have to go fetch the right decoder for the right vendor to make it all work right together here. So when it's all said and done, we should get just single command periodic fleet monitoring and not have to fetch a bunch of standardized pages as well as potentially vendor unique pages. And it'll give us an open industry standard failure analysis and meet the requirements for human readable debug output. So pretty cool. Solved a lot of problems. So real quick, there are 4 data areas in the telemetry spec of NVMe, and we are now standardizing on the top 2. So the data area 1 would be for fleet monitoring and is standardized, and the data area 2 would be for fleet drive debug, which would include data area 2 and reason identifier. In terms of issue difficulty, we have targets. I think different companies have different opinions on this. I know for Micron, our goal is to try to get about 80 to 90% of all device failures that may occur to be resolved in this industry standard way. We are just recognizing and saying out loud that potentially there'll be some even more difficult issues that may require vendor unique logs or data area 3, 4, and in the absolute worst case, physical access to the drive. And various customers managing their various fleets have different opinions of it. I've heard some customers say, we'll happily give you physical access to the drive after we shred it as a bag of dust. You know, so it's like, okay, that didn't help here. So in any case, the idea is for the most part, for a preponderance of the bugs that we might run into, we have a standardized method of decode and debug of this. And then over time, our goal is to kind of push that line down as far as we absolutely can. So for fleet monitoring, as we mentioned, just periodically probe data area 1, the OCP CLI plugin, along with the vendor unique string decode log page, which Mike will go into detail, will generate a human readable output. The human readable output can then be inspected by the data center security folks. They can look at it and go, yeah, that doesn't look like this contains any proprietary or custodial data that we're holding on for our various customers, and then that data can be released to the vendor for analysis. And so the idea would be if we got periodic monitoring of this data and this data could be offered to the vendor, they can data lake it, then the vendor can start creating more advanced failure analysis models that includes the fleet data, not just necessarily our own qualification data and our own factory data as well. We can start including a broader sense of data which will help us refine our own failure tuning and optimizations over time. Comments, questions? Debug's the same way, other than now we pull into data area 2. And the data area 2 would then identically get brought in. This would be in a case when the drive that has ran into a failure case. We pull in the additional debug level information, reason identifier data. It will get decoded and brought available to the vendor for analysis. Mike will go into this in way more detail, but in general, the green area is the low latency, and that's data area 1. So it's architected and designed to be so it can be periodically probed by the host and captured and offered to the vendor in a low latency manner. Anything beyond data area 1 could be a high latency event, and if we're obviously in a debug scenario, that's okay. So we call out that these are higher latency events. And then we can push all the way into data area 4 with some of the extensions that are in NVMe 2.0 that allow you to get some data. And then finally, there may be an unconstrained amount or a very sizable amount of data in data area 4, as includes the vendor unique crash dumps and whatnot. So again, the green and blue areas are decodable and human readable, and data area 3 and 4 is kind of the last little bit of information that you might need to try to debug the worst case scenarios. And with time, we hope it's limited. With that, if there's any questions, I'll pass it off to Mike. Mike will go into some of the more specific details of how the spec is constructed and how it all works. And feel free to ask questions anytime.
My name is Mike Allison. I work for Samsung. I'm a Senior Director of Standards and working on OCP, NVMe, and here we go. So here's the telemetry log, both for the host-initiated telemetry log as well as the controller-initiated log. And as he said before, there's 4 data areas. Initially, there was just data area 1, 2, and 3, which was limited to, I think, 32 megabytes. Data area 4 is much larger, and that's a negotiated agreement between the controller and the host of whether that is supported and used. This is all in the NVMe specification. I do want to say, though, that there is a new technical proposal that's been ratified, TP 4109, and what that allows you to do on the host-initiated telemetry log, when the host sends the command to go read that log, which it can also say, go capture the log on the host initiated, he can pass in the data area that is supposed to be the highest number data area to be captured. So if the host just wants to capture data area 1, they send this down, the drive just captures data area 1. Today, without that TP, you say go get a host-initiated telemetry log, you have to store all of that information. So when he talked about low latency, that isn't going to work because they have to store everything as though crash dump happened. So if they wanted just to get data area 2, then they would say, hey, give me data area 2, but then you'd also get data area 1. So the host is going to be able to control which data areas could actually get trapped and saved in the log page and then future read. The other thing I want to point out, because as I go through this, I'm going to go through data area 1 and data area 2 and the layout, but it's also important to say, hey, if I start at the top, how do I find everything? In NVMe, what they do for the data areas is they tell you the highest 512 byte chunk that contains the various data areas. Data areas are optional. You can just have data area 2 or data area 1, 2, and 3. For this one here, I'm just assuming you always have all the data areas as we go through this presentation. So let's go look at data area 1 that we're defining there. It's going to have 4 items to it. First of all, it's going to be fixed in size. There's going to be just an absolute fixed size for the data area 1. It's going to have a header that's going to describe both data area 1 and data area 2, and I'll get more into that. It's going to have an area for statistics. Okay, statistics is just a variable. You can dump a variable. Okay, variable sized, and we'll talk more about it. And then you can have 0 or more FIFOs. There's going to be a maximum number of FIFOs that's available to be reported overall, but those are going to be just the ones that are in data area 1. If you don't use the full size, you will have a 0 padded at the end. I just went where I didn't want to go. Excuse me here. This is not my computer, so let me. I need to go, well, your cursor won't let me go down, so how do I get back up?
Up there.
Well, it's going to be really ugly. All right, hold on. We're going to go way up there. I'm just going to go up to the top. All right, sorry about that. Not my computer. I just did it again. Okay. We'll try that again. Middle button. All right. All right, so we're getting there. Oh, I went too far. Now, there we are. So one of the things the header is going to do is to tell you where these things are relative to data area 1. So it'll say, hey, here's where the statistics are and how big it is, and then how many FIFOs are in here and where they are located. So if we want to dive into the statistics or the header first, I'm getting ahead of myself. We're going to have a version, profiles is where, hey, here's how data area 1 and 2 are loaded, but a different profile can put different statistics, different FIFOs, whatever, and you could be able to change profiles. So for example, you could have a normal running one and something happens, you can load one in that debugs even more data, so it could be dynamically changeable. There's also going to be some additional logging information in there in terms of the smart logs that are available between NVMe and OCP. If we look at statistics now, it's basically there's going to be n number of statistics. Now, unfortunately, when I realized as I was looking at this slide set earlier today, these statistics, even though it shows that there are n plus 1 in there, they are variable sized. So one could be 1 byte, one could be 20 bytes or whatever. This is just a formatting of what to do. The number that's in there is vendor defined. You get to put in there how many you think you need. If we look at the individual entry there, you're going to find that there's a variable set of fields within there. The first one is the identifier. And the identifier can say, I'm an OCP defined event, which is defined by the specification, or I'm vendor defined. And we're going to talk more about vendor defined. When we talk about the human readable thing, anything that's OCP defined, you already know what the definition is, so we don't have to define that later. You're going to find out in the strings page. The strings is just for vendor specific strings. There is a persistence which says for this data item, does it get reset at every controller level reset? Is it persistent for the life of the drive, life of a namespace, or whatever? You're going to identify how it's manipulated for the different times of resets. And the variable may be part of a namespace. And if it is part of a namespace, which namespace did it come from? And then you'll get into the data size. The data size is variable size, so you'll have to indicate the size. And these will be packed in thing. We're not going to have a lot of padding because we have fixed size of what we want to do. When you look at the FIFO, it's a FIFO. You get to define how many entries are in your FIFO. You get it, and it's vendor defined what goes in there. And when we look at an individual FIFO, there's several things that are in there now. There's a tuple of information. First of all is the debug type. The debug type it's a PCI type issue. It's a reset. It's a vendor specific issue. You can have different debug classes. All right. And then there's the actual identifier. So for each debug type, then there's identifiers that tell you what they are within there. This is an NVMe controller level reset. Okay. So the debug type could say I'm NVMe, and then the other one could say I'm a controller level reset. Or it could be a vendor specific. I'm NVMe, but it's my vendor specific type of identifier. So there's vendor specific and OCP defined both for the debug type and the identifier. The data then is the data defined by OCP, or you can have vendor specific data included with the OCP defined data. So now we have not only you can have entries that are just vendor defined, but you can also do an OCP defined and then add additional vendor specific data. The OCP header will have a pointer into the starting of each section within data area 1, and that is always going to be relative to the entire data area 1 area. And then there is data area 2. And data area 2 looks just like data area 1. It just has a different set of FIFOs and statistics in there. And as we said before, there's different latency requirements. You have to have lower latency for data area 1, and you can have higher latency for data area 2. The vendor gets to pick what they're going to put where and in which group. There is no size restriction going to be put on data area 2, other than the size restrictions as defined by NVMe. The header is also going to tell you where in data area 2 the different elements exist. So now we have this structure here, so how do we generate human readable stuff? Well, what you want to do is every one of these had data, so you can print the data. Every one of them has an ASCII string. So for the OCP-defined ASCII strings, they're known. The spec tells you what they are, so the parser tool can just hard code those in directly into the tool. The problem comes when you go to the vendor. How do we go and say, what does this mean to Samsung? What does this mean to Micron? What does this mean to whatever the device is there? And so there's going to be this new log page called the strings log page. And what goes in is your vendor specific identifiers, and what comes out is an ASCII string. So this way, when you generate your report, you can say data, and you could say, here's the string of what the definition is. And as you said before, then security can look at that and say, yeah, that's valid data, we can send it to the vendor. Because we do have customers that are in a data center that you cannot get opaque data out of there, and it makes debugging really hard with the telemetry. So let's look at the strings log page. There are 4 sections to it. As I said before, we had statistics that had vendor-specific stuff in them. Then we have vendor-defined events in the FIFO. And then we have vendor-specific data in event on an OCP-defined event. And so each one of those tables are the lookups for the vendor-specific identifiers, and then the ASCII strings are all the ASCII strings for all of this stuff. So if you were, the header just has pointers to where each of these sections are, and then they're all relative to the start of the strings log page. When you go look at the statistics, you have to put them in order of there, so your parser knows that these are in order. When you look at an individual entry, it just has the vendor-specific identifier, how big the string is, and then it's going to have a pointer into the ASCII strings relative to the ASCII string section. And so then when you look at the other areas there, they're very similar in pattern. They're smallest to largest. And here, remember I said that when we're looking at events, you have a debug type, and then you have an identifier, so there's a tuple of information for the lookup, and not just a single identifier. And then from there, you have a length and offset and where the strings are. There's not going to be any requirements on the strings where they fit in the strings there, but the ordering is definitely done on each of these string tables to do the lookup. And then finally, you get to the other, the identifier for that gets where you can add vendor-specific data to an OCP-defined event, and it has the same feature in terms of lookup and it relative to there. So it's pretty straightforward in terms of a formatting. They're very flexible, variable in size, and the intent there is you can read them out. So that's it. It's pretty simple. Any questions? No questions. Man, we're really good. Okay. No questions? Everybody understands?
I think the interesting push-pull that we're trying to battle is from the history of the days of SMART. Suppliers wanted to offer as little data as possible, and the customer wanted as much data as possible. And there was kind of a push-pull that had happened. And in the history of SMART, T10, T13, we kind of carved the places for data without actually specifying what it was. NVMe at least got that in there. It's going to be the same thing here. I think there's going to be a push-pull I think the vendors are going to have to deal with, which is this is really useful data to help us evolve and refine our future failure analysis models, but we're going to at least have to put it in enough to make it readable, get it decodable. And so I think there's going to be this interesting discussion, which is, the way I've described it is, some of these parameters may require not only a PhD in device physics, but maybe 10 or 15 years working for a specific company to even appreciate what that statistic is even trying to communicate. And the customer and the security officers are going to want to know what this is to some extent, but we've already said we're not giving you a PhD dissertation on what some of these parameters mean. At the same time, it would be nice to get some of those in there. So I think it's going to be an interesting exercise pushing forward in here. And the more we can put in here, the better we can improve our, ultimately our AFR of our fleet drive. it's in the best interest of everyone to get worked out. So that'll be an interesting conversation.
In T10 and T13, we sort of suffered because people implemented them before we got really precise about what they meant. So everybody measured them a little bit differently. And so every system house clamped down on how you actually measure each one. And the system houses weren't aligned, so we had an awful lot of stuff to go do. Well, what made that even more fun was then open source developers wrote what they thought it meant, which actually aligned with reality sometimes. So hopefully one of the things we'll have to worry about is when people actually write interpreters for this, to make it available for the average Joe Bob, that they actually have an idea what the heck they're talking about, because the amount of misinterpretation stuff which happened in SMART was awful.
It'll be definitely an interesting conversation. We're going to want to put some parameter. We don't want to describe it in great detail, requiring a PhD dissertation at the same time.
Yeah, has to be enough.
We probably can't call it mystery string 1. You know, it's probably not okay.
ID 1, ID 2, ID 3.
Yeah, so that'll be an interesting negotiation that's going to happen. But we've plumbed in all the capability to do this, and you know, with any luck, as this gets deployed out and used broadly. Also with a call to action that the customers need to offer this data back to us, so to the vendors, so we can run our own analysis and our own improvement modeling that will happen against a data lake of actual devices.
So one other thing, though, that I do want to mention about the strings log page. The intent of the strings log page for a given product is meant to be able to parse any telemetry log page that ever existed for any firmware update of that device. So let's say you deliver a drive, and I generate a host-initiated log page, and I parse it out. I save that log page, and 5 firmware updates later, I want to reparse it. I can reparse it. So if your code happened to get rid of a statistic, you still have to keep the definition into the strings page because it's supposed to last for the life of the device. So take that into account when you're managing these strings log pages.
That's a fine point I don't think I appreciated. So it wouldn't be you would read the log page as you were reading the data area 1 for that particular firmware for the decode. The log string page may have been cached from
long time ago. Like, they're not going to do parsing of everything. They're going to save the log pages that get generated, and then if they need to go back in time, they can. If a firmware update happened between there, they don't have to go back to a previous version to find the strings log page. Yep.
And reread the string
Yes.
log page to get updated.
So that means from a device point of view, you have to account for changes that happen in firmware update, that you have to keep previous data in there that may not be.
What if you want to add a new one in it?
You can add a new one, that's not a problem, but you can't get rid of an old one.
But you won't be able to decode with an old cache string file.
Correct. Correct.
So you'll have to read the string file every
Right. So in other words, they can go take any previously captured data, go to the existing drive, get the strings log page, and parse it out.
So part of the call to action beyond this as well is there is an initiative to get the OCP CLI decode tool. So help with your vendor data, looking into this, and help get the bugs out of it. Rusty, anything more you want to say about any of that? Or?
No. Did you deliver me drives this week?
What's the answer? Yes.
Any questions? Yes.
So your proposal included the FIFO base or something. FIFO base.
A FIFO.
Yeah. How often does it write written data?
So the thought of the FIFOs is it's going to support up to a certain number, with the intent there that the vendor gets to define how many FIFOs they need to use. One rule of thumb is try to avoid locking mechanisms to minimize that impact to your system if you can. So let's just say you build a device and you have 4 internal CPUs. Each CPU can get 4 or more to avoid locking. When you log data is up to the vendor. The real intent is If you have an issue, I should be able to dump this out and figure it out. You vendor, figure out what data you want to put in there so we could figure out the problem. Steve just said, I want to get 80 to 90% of my stuff debugged using this event. So his requirement then, from what I heard, if I was one of his engineers sitting there, is I just got my requirement from an architect that says I better have enough data in there to meet that statistic that they're driving.
There's a lot of ways to play this out, and this is why we left it very late. One original vision I had was one of the FIFOs would just be the lifetime log. So it needs to last over the entire life of the drive. And it's just going to have some major event types in it, maybe a retired block or XOR recovery or some small number of statistics that you can keep over the life that you would just, when one of those events happens, you can add it. You might have a medium FIFO that lasts a day or two, and then one of them, maybe that third FIFO is just what happened in the last 5 minutes before something happened. And that's one way to do it. Another option is, as I've seen the guys discuss, just snapshot the statistics in a FIFO periodically, and so you can just watch the statistics evolve over time that way as well. So there's a lot of ways to do that, and we didn't put any restrictions on how to do that. That should be architected the best the vendor can conceive of to try to support the initiatives that the hosts are trying to get to, which is just A, predictably catch failing drives before they go out of service, B, reduce that quantity, and C, once a failure does happen, just efficiently get through the debug. And I think I've heard Ross say this a couple times here. This should speed up debug a lot because it's not, oh, I gotta go find what vendor unique pages I gotta read and find the decode tool and figure out how to get all that done. It'll be the exact same process and the exact same methodology for every vendor.
Another rule is if you're developing an SSD, then use this to debug because your customer's going to, right? And if you can't, they can't. So take that. So a lot of the flexibility is left to the vendor. This is really a reporting capability in a structured way that we could generate stuff. You know, every implementation is a little bit different. You can't just, I can't give you a script to tell you what you should put in, when and why. You get a pick, okay? And, you know.
Yeah, so do you consider any redundancy about if crazy? I mean that if starter failed, but the non-broken, the all data.
So again, what you're really asking about redundancy is you get to log whatever you think you need to log, and if it's defined by OCP, then you could say, here's my OCP definition. If it's something internal to me, like something about my NAND, then I can create a vendor-specific one that says, I have this problem with my NAND, okay? So that's why we have the vendor-specific strings, so you can say, this is my problem. It may be unique to my implementation, okay? So this is just the reporting mechanisms. You get to pick what are the things relative to what you want to report. And it's just not all about NAND. It's about anything about the device, temperature stuff, anything that needs to do, PLP, whatever, okay? You get to pick what you want to do. And it's just more of they're guaranteed to parse it out kind of thing, okay?
Isn't that vendor unique, by the way? I've got a close friend that works in the biotech world, and every test they run has to have an attestation saying it was a legitimate test on this date, this time. If you wanted to do that, you could do that as either a statistic or a vendor unique FIFO or anything like that. How do we know that the data from data area 1 was actually reported from the drive as opposed to possibly even manipulated? You could do that if you so wanted to. So from if you're worried about redundancy or whatnot, you could certainly throw a CRC in there or something like that. And, that is the vendor unique field. There's opportunities to do a lot of things.
Kind of subtle, but it's expected that when a profile is selected that defines what statistics and FIFOs are going to be where, that profile is for the host-initiated telemetry log, which is then controlled by the host when to take a snapshot. And it also goes to the controller-initiated telemetry. That's the format, okay? The contents of the data that actually gets in there is the data at the time when the log was created, okay? So you can have multiple, you can have a host initiated that happens just right before a controller initiated. They'll have different data, but it's going to be formatted the same, assuming the profile wasn't changed, okay? Anything else? Yes?
What's a little confusing is the device may want to save as much information as possible. Will the host restrict that?
So let's go back.
So like SSD vendor, you want to save as much as the information.
Okay, so on the left, we have the NVMe defined telemetry log. Data areas 3 and 4 are still opaque and still could be as much information as the vendor would like to do it, but there's no way to read it out and print it out in a human readable form. So if your device is in a data center that says no opaque data ever leaves the data center, you can never get that data. So data areas 1 and 2 are now going to be formatted so you can get the data. Is this going to give us everything we could ever want to debug every little problem? Absolutely not.
So if the device vendor will have no access to the areas 3 and 4, so what
No, device vendor has access. Device vendor always writes data area 1, 2, 3, and 4.
Right.
Okay, when requested. So for a controller initiated, you write all of those. If your controller finds a problem and you generate a controller initiated, you always write the entire set. In the host initiated, the host is going to come in and say, I think you have a problem. You may not know it. I want you to take a snapshot of your host initiated log page. Or the host could say, I'm having a problem in my data center. I don't know what it is. I'm going to go out to all my drives and say, I want you all to trap your host initiated data, and I'm going to go figure out what's happening. Okay? In that call, on the host initiated side, the host gets to say, what data areas does he want you to collect? He could say, I really have a major problem. I really want you to create a log for everything, and we're going to find a way to debug it. Or he could say, I'm just doing a monitoring. Just go get me data area 1, and I want to get some data out of it. Go trap that log page. I'll read out the log page will just contain data area 1. And since it has a low latency, it's not affecting the IOs that are happening in there. And then I can get some data out live while it's running.
Okay, I got it. So it looks like the host initiated has more freedoms.
The host initiated, it gives the host the ability of when to take a log snapshot. Okay? The contents are always defined by the vendor. Okay?
So very early on, I was like, can I get 15-minute periodic sampling of 32 megabytes of data? And they went, absolutely not. That's way too much data. I'm not going to snapshot 32 megabytes data area 1, 2, 3, every 15 minutes for an entire fleet of drives and send it all through. And this is where we did come up with the idea that data area 1 is restricted in size. I think it's, is it formally called out 16 kilobytes?
Something like that.
Yeah, I think that's the number. It's, so that data area 1 that's meant for periodics, maybe many times a day snapshots of data then shared with the vendor is limited to 16 kilobytes. And it has other stuff in there. So you're going to be a little careful what you put in there before you run out of space. But put your best stuff in there for periodic mining. But other than that, the assumption is since beyond data area 1 is a high latency event, you're probably only going to do that in a debug scenario after you've identified a health concern or the drive has gone down is when you would start reading the other data areas, which gives you effectively nearly unlimited amount of data that you can do.
So another question, trying to help me understand this is, so if I'm on Micron, I have to build this for Samsung. Is the structure will be different for another?
Each OCP defined product, SSD, will have this structure put into them, but the contents of how many statistics and how many FIFOs is going to be different for every.
The structure is same. whatever fill into that structure.
It's going to be, I'm going to say, not only is it going to be unique to each vendor, but probably with different products with vendors, it could be unique depending on what their implementations are. Okay? That's why the strings log page has to be for a device. It's got to last for all firmware updates of that device. So there's no requirement that a company has to be the same across all products. It's just that product. So essentially, they can just go at any time to the device, get the strings log page, take a previously dumped data that they saved somewhere, and generate the text that goes along with that.
Let me give an example. In Micron's past, we had a fleet of drives that we were monitoring. And this was before kind of the clamp down of no opaque data going out, and we were seeing it. We saw a very minor population of drives in the fleet acting very, very peculiar compared to the rest of the drives in the fleet. And we saw that not from the standardized SMART telemetry, but by some of the vendor unique telemetry we had at the time. We ultimately root caused that to, we had a small handful of drives that were doing some experimental firmware during the quality debug phase. And somehow after that was done, they just tossed them into the fleet. And that firmware was never intended to be tossed into the fleet. But we were able to find these things before they actually failed. They would have failed earlier too. It was that particular experimental firmware was chasing something that we weren't trying to necessarily make it qualifiable at that moment. And we were able to identify and find those things. So, you know, there's going to be potential accounting, things like that, but just also, when we get smarter and smarter with this, we should be able to absolutely tune our failure prediction, failure capability, and failure mitigation. My hope is a bunch of fleet data then goes into better screening of NAND components, better screening of NAND at the SSD levels, in current generations, and then in future generations we can design some of that stuff.
Yeah, I definitely see the benefit. I just confuse there are so many data. If this is now the industry standard, then there's a vendors on this side, there's a customer on this side. There's going to be so many different combinations. What we so-called unique.
This will be in the way the standard is set up. You can choose to not implement any vendor unique anything.
Correct.
And not and those vendors will, you know, ultimately distinguish themselves or not distinguish themselves by how they can use this data lake of fleet data to help improve their designs over time, and or not. So it's really not literally the minimum implementation spec would be to just snapshot the SMART and then OCP log and nothing else.
Yep.
And so it's going to be unique. Again, it's a little bit like my car debug port. I plug in my 15-year-old truck versus my new hybrid electric. I get very different telemetry coming out of it because there's different things in the architecture unique to that architecture. But it does report the standardized way.
So where is this going to live?
This is going to live in an OCP standard.
In a separate one or part of a data center SSD?
I believe in the data center SSD. Any other questions? All right. Well, I appreciate you all coming and listening and asking questions. If you have any other issues, talk to Ross. Thank you.